Hello everyone, I hope you all are doing good. So in today's data structure tutorial, I'm going to talk on depth first search, where we traverse the graph in a depthward motion. So we traverse the graph in depthward motion. We use depth first search for finding any cycle in a graph if we want to determine any cycle is present in the graph, or if we want to know about the strongly connected components, to find the strongly connected components in the graph. I would like to describe it by using an example. Okay. So I just mentioned that in depth first search, we are going to traverse in depthward motion. Okay. So if this is my graph, the first node I'm going to traverse is A. Then from A, I'll be moving to B. Then further depth, that is D. Now I'm done with these three nodes, right? So the first depth is done. Now we will move to E. Fine. And then after traversing the entire depth on the left hand side of A, I'm going to traverse C. Okay. So I'm going to implement it in C++ by using the example that we have solved in the breadth-first search tutorial as well. Okay. So I'll just give the brief again, how we represented graph in C++. I just created a class where we was denoting the vertex, and for every vertex we keep the list for the adjacent list. Okay, so my adjacent list, I have the list of vertices that are adjacent to the particular vertex. So for 0, the adjacent list will be 1 and 2, right? So then in add edge function, we were adding all the edges that were connecting the vertices. Now let's see how we are going to implement depth first search. So I'm going to create a function void dfs demo, and I'll be calling this function from my main function. So I'm going to call g dot dfs demo. Okay, inside now let's define this function. Return type, class name, function name. So the first step is every node is not visited initially. So I'm going to create an array of Boolean type with name visit, and the size is going to be v. Okay, the number of vertices. Then using for loop, I'm going to initialize all the vertices as false. That they initially we have not visited any vertex. So I equal to 0, I less than v, and my visit I equal to, I'm going to assign it to false. Fine. Now the next step. For every vertex, let's take a loop. I less than v. Check if it is visited or not. If visit I is false, what we are going to do? I'm going to call the depth first search. So I am going to use a function that would be repetitively called for every vertex that is not visited. So let's create that function, void dfs. Now here I'm going to use two parameters. Number one is that vertex itself. I'm going to name it as root, and if it is visited or not, to keep track of that, I'm going to put boolean visited. Okay, so I'm going to call dfs I comma visit. Fine. Now let's define this function. So return type, class name, function name, and the parameters, and root comma bool visited. So the root is going to be visited now. So I'm going to assign it true here and print root. Okay. Now I'm going to create a list iterator. So list type is going to be int iterator. Okay. Now here if I'm taking this node, initially it is false, it is not visited. When I am entering the dfs function, here it is visited, so it will be true, and I'm going to traverse the adjacent list. So my first is going to be 1. So if this is visited, the next one I'm going to visit is 1 and 2. These two are there, right? But it will first move to 1 and it is not visited. So the red ones are not visited. Now when 1 is visited, I'm making it green, and again I will check the adjacent list of 1. Before covering all the adjacent list of 0, I'm going to check the adjacent list of 1. So I will move to 2. So this will be done. Now here I am at vertex 2. So I will check the adjacent list of vertex 2. Then I will be backtracking to upwards. Okay. So here the adjacent list of 2 is 3. So I'm updating it as visited. Now this is done. When I'm going and checking the adjacent list of vertex 0, 1 we were good. Now I'm checking 2, but 2 is already visited. So I do not need to perform any function, right? So the same logic I'm going to implement here by using a for loop for iterator equal to adjacent of root. Root is every vertex that we are traversing. Begin and iterator not equal to adjacent for that particular vertex root dot n it plus plus. Fine. So next step is if not visited that adjacent element, then call the depth first search again. Okay, depth first search of value stored at that particular iterator and visited. Fine. So we are recursively calling the depth first search again and again if that particular adjacent list element is not visited. Now let's run this program. Okay, I have missed on one semicolon. Okay, now we run it again. See, the depth first search 0, 1, 2, and 3, right? Because here in the loop, I'm starting from my vertex 0. I'm going to provide the GitHub link in the description section. Do check out and please play around with more complex graph parameters. I hope you like this video. If you want me to touch on other topic related to graph traversal, please feel free to put in the comment section. Thank you. Have a good day.